All right, everybody. Welcome to What Are Normals? In this short series, I want to go through and just explain what normals are and how they work. You know, we're going to start at the very, very beginning, and we're going to work our way up to baking, right? So if we have a look here on the left, this is a high poly model. I think it's something like a million or two maybe 3 million polygons or something like that. You can see all the complexity and the detail, all these bricks. You know, we've got depth, things coming off surfaces. Really high res model. And then on the right, we have a model that's like, I don't know, 300 polygons or something like that. Very low res. But if we turn on our normal map, you can see now that we have faked the detail of the high poly on the low poly. And if we have a look, the obvious thing that's missing is the depth, the actual depth within the geometry. But for all intents and purposes, on the surface, it looks identical. So this is the isolated normal map. But if we actually bring in all of the colors and the roughness and everything, you can see that combined together, we can create a model that looks quite nice. You know, we've got roughness and metallic and all kinds of things happening. But you can see that if we actually turn off the normal map, you can just see how flat the surface is, you know. So normal maps add a tremendous amount of detail, faking the complexity of a surface when in fact they're incredibly simple. All right, so all of the concepts that we're going through in this series are software agnostic. They work in Unreal, Blender, Maya, C4D. It's all the same thing. For most of this series, I'll be using Houdini because it gives me the ability to explain these concepts at a very fine, granular level. So let's dive in. First thing I want to talk about is face normals. So if we have our, quad over here with our points. If I click on this button over here, we can actually see our face normals. And a face normal is essentially just that. It's a point that is perpendicular to a surface, and it gives us its direction, right? So if we have a look underneath here, this is the back side of the face, and this is the front side of the face, okay? If I then subdivide these, you can see now we have 4 quads, and each of those quads has a face direction, all right? If I click on this to reveal our normals or our point normals, you can actually see that these green lines appear, okay? Now what these are, these normals, is when 2 edges meet to create a point, then that point needs a direction, like which way am I facing? Okay, and generally they select the direction that the face that they make up is pointing. Okay, so you can see they're all pointing in this direction. Okay, so let's turn this off and move on. So if we see here, actually turn this on, you can see over here now, I've split this into 2 triangles. And over here you can see where these 2 edges meet, we have one line or one normal that's pointing out. But over here, there's 2. And this we'll get into in a minute, but it has almost everything to do with UV textures and UV layouts. For all intents and purposes, a point is made up of one or more vertices. So if I hit the S key to select and I go to point selection, you can see I can select this point and I can move it. Hooray, right? But if I go to the vertex selection, so we can select our vertex, and as we know, a vertex is the point when 2 lines intersect, you can see that I can't actually move these. If I hit the T key to move it, it won't allow me to move these vertices, right? And that's because, see, even here, if I do this, it's moving the point. It won't allow me to move the vertices. And that's because this point is made up of these vertices and you can't actually move them, right? That's just how it works, okay? If we move on to this example over here, you can see that we now have these 4 faces And on each corner over here, we have our 2 vertex normals because our point is made up of these 2 vertices that make up the polygons on either side. And in the middle, we have 4. So if I click this button over here, you can see that we have 4 vertices because this point is made up of these 4 vertices that make up the faces around it. Okay. Now, I'm just going to exit out of this. We can transform this point. So I'm just going to take this point over here and move it down. And you can actually see now that these vertices aren't pointing up anymore, or these normals aren't pointing up. See if I shift it, right? And what's actually happened is because these are all connected, right? Sorry, the vertices over here are all connected. When you actually change this, they kind of go, well, where do I point, right? I don't know what to do. And if you have a look at it, it just says, okay, I'm just gonna take this face direction over here and this face direction over here that I made up of, and I'm just going to do the average of that and point in that direction. If we have a look at our this node where we give normals to vertices, you can see this cusp angle is 60. And if I move this down, when we get to this point, you can see it's splitting. And the reason why it's splitting is because this angle here is less than this angle here, okay? If this is greater than this, they combine, they average. And if it's not, they split, okay? And we're talking about this angle over here, okay? And this is where we first start seeing the idea of how normals affect the shading or how light interacts with the surface. So if we crank this up, you can see that this is nice. It looks round, even though it's not round. And if we bring it down, you can see it's split, okay? And generally when you read forums or talk to people and they start talking about hard and soft normals, when normals are split like this is creating a hard edge. And when they're not, it's creating a soft edge. So they're essentially just talking about split or averaged normals, okay? Now, if we then change this from, so I'll just put this back to normal. And what I'm actually now going to do is I'm actually going to split the points because everything that we've done has just been splitting the vertices underneath. But if I split the points, you can actually see now that the normals, even if we bring them together, right, because they're actually split, they're 2 points, they're actually just going to inherit their direction from the face that they're connected to. All right, hope that makes sense. So even if we change this cusp angle, it's not going to do anything because there is no cusp anymore because the points are actually split. Okay. So I want to now talk about point normals. All right, I'm going to turn this split off. And if we have it, look now, it says add normals to the vertices. So what we're doing now is we're adding normals to each of these vertices. But instead of adding them to the vertices, we can actually add them to the point, which is the blue thing. And if we go add to the point, you can see what happens here is, firstly, the cusp angle goes away. And we can't change that. And the reason is because these points, they get their direction from the vertices, right? They go, okay, I'm made up of, in the case of this, I'm made up of these 4 vertices. Which direction are they all pointing? I'm going to average those directions, and that's the direction that I'm going to point, okay? And you can see that even if when we split this, so you see we can change this nothing, but if we split this, you can see now, because these vertex normals are pointing up, that this point normals go, okay, I'm just going to find the average. Because these are pointing this way, the vertex normal, the point normal averages that, okay? Hope that makes sense. All right, so I'm going to turn, yeah, that's fine. And we're going to go to this example. And this is where we're going to talk about UVs, okay? So we see we have our face, it's got some UVs on it. So if I have a look like this, and you can see that if I split this face off down here, you can see how our texture moved. See like that? Because these edges are together, you you can see that there is no seam. It's perfect. But then if I split them off, you can see how the texture has moved, all right? And that's the reason why we have vertices, is because each of these face in our texture needs a coordinate system, right? So if I can't edit the UVs in the 3D viewport, so come on, I can't edit them here, but if I go into here, I can absolutely edit them. If I select that, hit T. Oh. There you go. And now I can absolutely move it. And when I move it, it's not moving the geometry, it's moving the UV island, okay? So that's why we have vertices and points. So that's why each one of these points here is made up of these vertices. So if I go into here and I select that vertice, I can move that. If I select that vertice there, I can move that. And if I select that vertice, I can move that, right? And you can see that's why they all have a normal, because these faces are like, which direction am I pointing? Okay, so in the next video, we're gonna have a look at point normals and explore how we can manipulate them to affect how light reacts with the surface.